The night is wide and still, and somewhere above you, the sky stretches farther than thought itself, past stars, past galaxies, past everything we've ever seen. But does it stop? Does space have an edge? Or are we floating inside something that never ends? It's a strange question, almost childlike. Yet the more you turn it over, the deeper it becomes, because to ask where space ends is to ask what end even means. Is there a wall waiting beyond the last star? Or does space curve back on itself, looping endlessly like a dream with no waking? You don't need to find the answer tonight. Just listen. Let your thoughts drift outward, past the noise of the day, into that endless dark that hums quietly beyond the horizon of everything we know. And if this quiet journey through the universe helps you unwind, if it lets your mind float a little lighter, you can gently tap like or subscribe, so this calm little corner of wonder keeps expanding. Now, settle in. The stars are waiting. Let's follow them and see where space might stop. Or, if it ever does, under the quiet weight of night, when you look up at the stars, you're really looking into space, that deep black ocean where light itself drifts like dust on a silent current. It feels empty, still, untouched. But space is not nothing. It only wears the disguise of emptiness. Beneath that darkness lies something alive, a vast, restless fabric that hums softly with motion and possibility. For a long time, people thought of space as just a backdrop, a kind of invisible floor on which the universe performed its dance. Newton pictured it that way, a fixed, absolute stage where time moved evenly for everyone, and matter simply acted out its script. But then came Einstein, with his chalk-dusted sleeves and that strange, knowing smile. He saw space not as a stage, but as part of the dance itself, bending, stretching, breathing in response to the weight of stars and the energy of light. Imagine a great, invisible sheet beneath everything. Place a heavy sun upon it, and the fabric curves. Planets, like small marbles, roll along those curves, not because they're pulled, but because they follow the shape of the space itself. This is gravity, reimagined not as a force, but as the music of the universe written into the texture of space-time. Every star, every planet, every atom presses its faint fingerprint into that fabric, shaping the paths of all things that move through it. But what about the dark spaces between the stars? Those silent distances that seem like pure nothingness. You might imagine them empty, but the truth is far stranger. Even in the loneliest corners of the cosmos, space quivers with invisible energy. At scales too small for the human eye, far smaller than atoms or light, space is alive with quantum fields. These aren't things floating in space. They are space itself. Every particle you've ever heard of, an electron, a photon, a grain of dust from a comet's tail, is a tiny ripple in one of these fields. And even when no particles are present, the fields never rest. They tremble softly, producing brief sparks of existence that vanish almost as soon as they appear. Virtual particles, flickering in and out like the breath of the void. If you could listen closely enough, you might hear it, a faint crackle beneath the silence. The softest hum of creation, continuing everywhere, always. Physicists call it vacuum energy, but that word hardly captures its beauty. It's the shimmer beneath stillness, the movement inside calm. From afar, the universe may look smooth, but up close, it ripples like a quiet pond touched by invisible rain. Those ghostly fluctuations are not without consequence. They shape how atoms hold together, how light bends, how galaxies drift. Some even whisper that this hidden energy, this quiet vibration of nothingness, may be what pushes the universe apart, feeding the mysterious expansion we call dark energy. So, even the space between things is not still. It's breathing, pulsing, stretching. And yes, space can stretch. Not the stars moving through it, but the very fabric itself expanding, like rising dough carrying galaxies farther and farther apart. It's not that the cosmos is moving through emptiness, it's that emptiness itself is growing. Each second, the distance between galaxies widens, the fabric of reality lengthening like a soft exhale. It can be dizzying, this idea that the quiet void is not quiet at all. But maybe there's comfort in it too, knowing that even when all seems silent and still, something gentle is always moving beneath the surface, a faint vibration that connects everything that ever was and everything that will be. Even now, the emptiness between galaxies isn't completely cold. It glows, just barely a few degrees above absolute zero, warmed by the fading echo of the Big Bang. That afterglow still travels through us, through our breath, through every atom in your body. The same light that began the universe still hums softly in the dark. So when you ask, what is space? You're not asking about nothing. You're asking about the most mysterious presence there is, the thing that holds all things. Space is not the stage on which the story unfolds. It is part of the story. It bends, it ripples, it expands, it hums. Even when it appears empty, it's never truly still. And if you've ever wondered where the edge of it might be, the truth is that we can only see so far. Imagine standing beneath a perfect, star-swept sky, feeling as if the universe stretches forever. Yet there's a limit, a soft horizon drawn not by walls, but by time. Beyond a certain distance, light simply hasn't reached us yet. It's not that the universe ends there, only that its story beyond that horizon is still traveling toward us, still unfolding. That faint boundary is what astronomers call the observable universe, a bubble of everything we can see and measure. You might think that bubble should stretch only 13.8 billion light years, the age of the universe itself. But because space has been expanding the whole time, the true horizon lies far beyond at some 46 billion light years in every direction. The light from those distant galaxies began its journey long ago, while the fabric beneath it kept stretching, like a wave riding an ocean that never stops growing. Think of raisins baked into bread. As the dough rises, each raisin drifts away from the others, not because it moves, but because the dough between them expands. Now imagine a single photon, a particle of light, leaving one raisin at the beginning of time, racing toward another. By the time it arrives, the universe has swelled around it, and the distance it crossed is far greater than when it began. Out at the edge of that vision lies what we call the cosmic horizon. Not a wall or a border, but a fading of what can reach us, like standing in a soft fog where the farthest glow dissolves into gray. Beyond that mist, light still travels, but it hasn't arrived yet. The universe continues on, unseen and silent, its signals still making their way across the dark. As time moves forward, more light will cross that gap, and our horizon will widen. But the expansion itself is quickening. Some galaxies are already drifting away so fast that their light will never reach us, no matter how long we wait. They're not breaking the rules of physics, it's the space between us that's stretching faster than light can bridge. In a quiet, inevitable way, parts of the universe are slipping beyond our reach, fading into in eternal distance. Yet even that thought, the vanishing of light, holds a kind of peace. The cosmos isn't disappearing, it's breathing. Each expansion, each stretch of silence is part of its rhythm. And here we are, floating within it, brief sparks of awareness, inside an endless, luminous sea that never truly stops expanding. The night stretches endlessly, quiet and blue-black, the stars breathing softly like distant embers. Every shimmer you see, every star, every wandering smear of light lives inside one great, invisible sphere, our observable universe. All the beauty we can capture, all the light that has reached us since the dawn of time, floats inside this delicate bubble. It feels enormous. 2 trillion galaxies, each one home to millions or trillions of suns, yet it's still just a fragment, a tiny window cut into something far greater. Beyond it, the universe continues on, wider, deeper, perhaps forever. The photons from those unreachable realms have not yet crossed the ocean of time to find us. We live inside this luminous cocoon, surrounded by an immensity we can only imagine. And here's a gentle wonder. Everyone, everywhere, has their own version of this bubble. If you were standing on a galaxy 10 billion light years away, your horizon would overlap ours a little, but it would also stretch into regions we can never see. Every observer in the cosmos is wrapped in a different sphere of visibility, each one defined by the patient travel of light. The universe gives every consciousness its own perspective, a private window into infinity. The light that fills this bubble is ancient. Some of the photons striking your eyes tonight began their journey when Earth did not yet exist, when no ocean shimmered under any moon. They've traveled across billions of years only to end their voyage as a quiet flicker on your retina or the silvered mirror of a telescope. Each ray is a message in a bottle from the distant past, crossing space's dark sea to tell us how the universe once looked, once breathed, once burned, and still, for all this brilliance, our view may represent only the faintest sliver of what truly exists. Beyond the edge of what we can see, space may go on without boundary, perhaps flat, perhaps curved back upon itself in some higher geometry our minds can barely sketch. We may never know. No signal limited by light can outrun that horizon. Yet there's peace in that limitation. The cosmos doesn't owe us completeness. It gives us a glimpse, and that is enough. There's humility in knowing we will never hold the whole. We belong to a particular place and moment, one bubble of awareness among countless others, and within this gentle confinement, meaning thrives. Sometimes it's enough simply to sit beneath the stars, feeling the cool air on your skin, and know that you are part of something immeasurably vast. 93 billion light years sounds impossibly large, but it's just the visible frosting on a cake that may have no edge. What lies beyond more galaxies, more dark matter, or something stranger remains a quiet secret. For now, we drift within this softly glowing sphere of light and time, a bubble sculpted not by walls, but by patience, by the slow persistence of photons on their way home. It is not a prison, it is a gift, an ever-expanding invitation to wonder. With each passing moment, new light arrives, carrying news from farther away, and our bubble grows just a little larger, the universe slowly unveiling itself to us like a dawn that never ends. When you look up at the night sky, it's tempting to believe you're seeing the universe as it exists now, but you're not. You're seeing it as it was. Every spark above you is a time capsule. The farther the light, the older the memory. The sky is a living archive of the past. Think of a light year. The distance light travels in 1 year about 6 trillion miles. When you gaze at a star 100 light years away, that light left its home when your great-grandparents were still young. The glow you see tonight is a memory of their time, not yours. Stretch that thought across billions of light years, and you begin to sense the scale of cosmic time. Some of the light we capture began its journey before the Earth existed, when the first stars were forming from clouds of hydrogen. Those photons raced through epochs, through collisions of galaxies and births of suns, until finally, tonight, they found you. Astronomers call this look-back time, the measure of how far into the past we peer when we observe the distant sky. A galaxy 8 billion light years away shows us the universe as it was 8 billion years ago, more than half its present age. To watch it is to read a line from the middle chapters of creation. Space, then, is filled with ghosts not haunting, but luminous. We see galaxies as they were, not as they are. Many have already changed or merged or faded while their light keeps traveling toward us. The sky above is a fossil record written in photons, a glowing diary of what once was, and there's more poetry in the physics. As light crosses expanding space, it stretches, its wavelength lengthens, its color reddens. This cosmic deepening is called redshift. It's the same effect that makes a siren drop in pitch as it speeds away, only grander, a symphony of the whole universe moving apart. By reading the redshift of a galaxy's light, astronomers can tell how far it is and how long its message has been traveling. A large redshift means the galaxy is distant and ancient, a window into the universe's youth. These stretched colors reveal the tempo of cosmic expansion, the growth of galaxies, and even the strange influence of dark energy that propels everything outward faster and faster. Every reddened photon carries both beauty and data, the memory of its birthplace, and the whisper of how space has changed since it began its flight. To gather those whispers, we build telescopes, our time machines. Even a small backyard telescope lets you see Jupiter's clouds as they were 40 minutes ago, the time it takes their light to cross the solar system. Larger observatories reach deeper, 500 million years into the past, when life on Earth still swam in ancient seas. And then there are the giants, Hubble, James Webb, and the ones yet to come, able to glimpse the first galaxies that ever existed. They see back almost to the moment when darkness first gave way to light, when the universe was just awakening from its cosmic night. It's ironic that to understand where we're going, we must look so far behind us. The universe reveals its future only through its history, because light, though fast, is not instantaneous. Everything we see arrives delayed. The cosmos we know is always slightly out of date, a film still uploading its frames across eternity. But that delay is a gift. It lets us see the universe's life all at once. Newborn galaxies and ancient ones, near neighbors and long-gone ghosts, scattered across the same sky. Time overlaps itself here. The heavens are a tapestry woven of different eras stitched side by side. In one direction, a young galaxy still forming stars from clouds of gas. In another, a mature spiral glowing with billions of suns. Between them lies light from epochs separated by billions of years, yet appearing together in the same midnight panorama. We live inside a museum made entirely of light, and unlike any museum on Earth, we don't walk through its halls, the exhibits come to us. Each photon travels unimaginable distances to deliver its story. When you look up, those stories merge and shimmer, a collage of cosmic history unfolding above your breath. There's something deeply human, deeply peaceful about that realization that your eyes, delicate, mortal, fleeting, can receive light that began its journey before the first tree, before the first drop of rain on Earth. The universe took billions of years to paint this sky for you. Every star twinkle, every faint hue is a word in a silent language written in motion and memory. Scientists translate that language into equations and measurements, but you can also feel it, the pulse of time made visible, the heartbeat of creation slowed to a whisper. The next time you gaze into the dark, remember, you're not seeing the universe as it is. You're seeing it as it was, stretched across distance and years, still arriving. Each ray of light is a survivor of an ancient moment, a messenger that has traveled through expanding space to find you here, tonight, beneath this quiet sky. So lie back, let your thoughts drift outward with those photons, past the edge of your own horizon. The universe will keep unfolding softly, endlessly, while you breathe in rhythm with its light, and in that rhythm, you are already part of its story. When you look into the night sky, you're seeing the universe as it once was, younger, smaller, and softer around the edges. Through the patience of light, science lets us piece together that ancient story, one faint glow at a time. Imagine standing in a meadow at dawn. The air is cool, the grass glimmers with dew. A pale fog drifts across the hills, hiding everything beyond a few quiet trees. You know the world continues, but you can't see it yet. That's what it's like to live inside the universe. Surrounded by distance we can sense, but never quite reach. No matter how strong our telescopes grow, there's a limit to what light can show us. Those limits are the universe's horizons, soft boundaries shaped not by walls, but by time itself. The first is called the particle horizon, the farthest edge from which any signal, any flash of light could have reached us since everything began. Because space has been expanding for 13.8 billion years, that distance now measures about 46 billion light years in every direction. It marks the perimeter of our observable bubble, a sphere roughly 93 billion light years across. But it isn't a wall. It's simply where the light has run out of time. Like standing on the shore of an unseen sea, you can gaze as far as light allows, but what lies beyond remains invisible, not absent, just unreached. A second horizon sits closer, quieter, and more final. The cosmic event horizon. Beyond it, light leaving right now will never reach us, no matter how long we wait. The fabric of space itself is stretching faster than that light can travel. Imagine throwing a bottle toward a friend, drifting down a river. The current carries them away quicker than your message can float forward. That's the event horizon, the point beyond which communication, even through light, becomes impossible. Today it lies about 16 billion light years away. Some of the galaxies we see hover near that line. Their ancient light is still arriving, but any new glow they send will never find us. They are already fading beyond reach. Together, these horizons form a kind of cosmic boundary. As time passes, the particle horizon grows. More ancient light finishes its journey, but the event horizon stays stubborn, a moving border of farewell. Because of dark energy and the accelerating expansion of space, more and more galaxies slip away. The universe isn't emptying, it's stretching faster than light can keep it stitched together. To picture this, imagine the universe as the surface of an inflating balloon speckled with dots. The dots are galaxies. The balloon's skin is space. As the balloon expands, every dot drifts from every other. The farther apart they are, the faster they separate. None of the dots move on their own, it's the rubber between them that grows. The galaxies aren't sailing through pre-existing emptiness. The emptiness itself is what's changing. This motion defines what we can and cannot see. Our view isn't limited by technology, but by the laws of space-time itself. Some corners of the cosmos are, and always will be, beyond information, not hidden behind a curtain waiting for us to discover them simply unreachable. Yet that doesn't make the universe smaller. The fog doesn't shrink the meadow. It only softens it, giving shape and mystery to what remains unseen. Within these quiet boundaries, humanity has already learned more than our ancestors ever dreamed. We've charted clusters of galaxies and traced their invisible scaffolding of dark matter. We've mapped the faint microwave afterglow of the Big Bang, the leftover heat of creation, still humming, only a few degrees above absolute zero. Each discovery pushes back the fog a little farther, revealing more of the cosmic landscape, even as new horizons continue to drift away. It's humbling and beautiful at once, knowing that our view of the universe is both enormous and incomplete. We are not outside observers of infinity. We are participants within it, travelers who can see only as far as light allows. Still, we keep looking. The act of looking is itself a kind of belonging. For centuries, people imagined the universe as steady and eternal galaxies, fixed like jewels in an endless dark. Then, a century ago, a quiet revolution began atop a California mountain. Astronomer Edwin Hubble measured the light from distant galaxies and found it stretched toward red. The farther away the galaxy, the greater the stretch. It wasn't random. It was the signature of motion. Not galaxies racing through space, but space itself expanding. To understand, think again of bread rising in an oven. The dough is space. The raisins are galaxies. As the dough expands, every raisin moves away from the others. None of them are special. From any raisin's point of view, all the rest seem to recede. That's how the universe behaves. Everywhere, from every galaxy, it appears that all others are drifting away. Expansion is uniform, woven equally into every direction. This realization changed everything. Even Einstein, who once believed the cosmos must be static, had to adjust. When his equations first predicted a dynamic universe, he added a term, the cosmological constant, to make it stand still. Later, after Hubble's discovery, he called that adjustment his greatest blunder. And yet, in one of science's quiet ironies, that same idea returned decades later to help explain the mysterious dark energy now driving the universe's accelerated expansion. What once held the universe still now seems to make it move faster. So space doesn't expand into anything. There's no outer shell, no boundary it's racing toward. Expansion happens within between galaxies, in the distances themselves. Locally, gravity keeps clusters bound, holding stars together in their spirals. But on the grand scale, the cosmic fabric lengthens like a deep breath. That expansion is what writes our horizons. Each moment, light from more distant regions finally reaches us, enlarging what's observable. Yet simultaneously, countless galaxies drift beyond the event horizon, their future light forever cut off. We see them now as ancient ghosts, knowing their newer selves are already gone from our story. It's a strange kind of goodbye, gentle, inevitable, part of the rhythm of time. Still, the universe gives more than it takes. The boundaries don't imprison us, they teach us how to see. They show us that even the finite can hold infinity, folded inside every photon that arrives. The light we receive tonight is a relic of unimaginable persistence, traveling for billions of years through expanding space just to brush the surface of your eye for a fraction of a second. Every glimmer carries the handwriting of cosmic history, temperature, age, motion, memory, all encoded in color. Even the silence beyond the visible has meaning. The unseen parts of the universe remind us that knowledge has edges, and those edges are not failures, but frames. They let wonder breathe. Like the horizon at sea, they give shape to what would otherwise be endless, allowing us to feel both small and complete. If you lie awake and think of it, the growing balloon, the unreachable shores of light, the galaxies slipping away, it might feel lonely at first, but listen a little closer. Expansion is not emptiness, it's movement. It's the universe continuing to right itself. The same physics that draws distant worlds apart also keeps the stars shining and the atoms in your body bound. You are made from the same fabric that stretches between galaxies, so let the limits be gentle. Let the horizons rest where they are. We live within them, not outside the universe looking in, but inside it, glowing softly with all its light. Even what we cannot see still touches us, through gravity, through the faint warmth of the cosmic background, through the quiet fact of our existence. We are stitched to the universe, not by vision, but by belonging. And somewhere, beyond the curve of time, new light is still on its way, photons older than Earth itself, traveling faithfully through the widening dark. They will reach us someday, perhaps long after we're gone, joining the endless chorus of arrivals. That is the music of the universe. Light always in motion, horizons always unfolding, and us tiny listeners drifting in its glow. The universe has a wry way of smiling at us. Just when we think we've pinned it down, it tilts the frame and invites us to look again, softer this time, slower. Hubble's discovery did that. By noticing the distant galaxies where their light stretched toward red, he gave us permission to rewind the cosmic film. If everything is drifting apart now, then once upon a time, everything must have been closer. So close that the universe itself was hot and dense enough to glow. We call that beginning the Big Bang, though the name can be a little mischievous. It wasn't fireworks bursting in a pre-existing night. There was no empty stage waiting for the blast. Instead, space itself swelled everywhere, all at once, like a breath taken by reality. No center, no edge, no first spark erupting from a particular point. The beginning unfolded here as much as there, and the expansion that started then has continued unhurriedly ever since. Think of it as the fabric under everything, loosening its weave. Galaxies did not rocket through space like thrown stones. The distance between them lengthened. As that fabric stretches, the light traveling across it stretches too, its color reddening like embers cooling in the night. The farther away a galaxy is, the more its light has been drawn thin by the journey. That quiet stretching of distances, of time, of color, shadows every observation we make. Yet the expansion is not a thief of teacups and chairs. On small scales, other forces keep their promises. Gravity locks stars to their spirals and binds galaxies into families. Electromagnetism holds atoms close and kettles to their handles. Your neighborhood doesn't expand. The Milky Way doesn't expand. Your coffee stays where your hand expects it to be. Expansion's hand rests lightly on the grand distances between clusters and superclusters, where gravity's grip loosens and the cosmic weave is free to lengthen. For a long time, most of us imagined that this expansion must be slowing gravity, tugging back, reining in the stretch. Then, near the end of the 1,990 seconds, the sky whispered otherwise, by reading the light of distant, exploding stars. Supernovae that flare with a known brightness, astronomers found the opposite of what they expected. The expansion is speeding up. The dough isn't just rising. It is rising faster with time, as though some subtle pressure in the fabric is urging it outward. We gave that pressure a name: dark energy. We don't yet know what it is. Perhaps it's a property of space itself, a gentle insistence present even where matter is scarce. Perhaps it is the echo of some deep field we have not fully learned to listen to. Whatever its nature, it now dominates the universe's balance sheet. On the largest scales, dark energy is the steady conductor, raising the tempo, turning a slow widening into an accelerating drift. There's something tender in that arc. The universe began pressed close, bright with heat and possibility. Over time it cooled, let structure form, allowed stars to ignite and metals to be forged, laid the ingredients for worlds and oceans and breath. Now it continues to lean outward, not in a shout, but in a long, quiet exhale. A story that opens in fire, blossoms into complexity, and settles into an endless, patient epilogue. If space had sound, perhaps it would be the soft creak of rising bread, the occasional bubble's sigh, the faint rustle of heat dispersing, not a bang echoing forever, but the hush of a room expanding, beams settling, floorboards relaxing while the night air moves through open windows. The beauty of it is how ordinary the rhythm can feel. Change as a gentle, constant creation, as a sequence of small widenings. So when we say the universe is expanding, we don't mean there's a central point we're fleeing, no cosmic hub from which everything sprays. We mean the measuring tape itself lengthens. Reality's grid stretches calmly, evenly, and the distances written on it grow. There's comfort in that picture, the way it allows vast change to coexist with quiet. The universe can be both immense and soothing, both dynamic and safe. And here we are within it, wrapped in that slow drift. Every breath you take, every thought that passes like a small cloud across the mind, unfolds on a rocky world orbiting an ordinary sun, carried in the gentle tide of expansion. The image can make you hungry for answers, or maybe for toast, some simple proof that rising dough is real, that what grows can also nourish. Of course, physics has its rules, and the universe keeps them with surprising grace. One rule is crisp: nothing with mass can move through space faster than light. Not a rocket, not a message, not even that cousin who swears he outran rush hour. Light sets the limit roughly 300,000 kilometers each second, and objects traveling in space must bow to it. And yet, we find galaxies whose separation from us increases faster than light could bridge. At first glance, it feels like a contradiction, stars and dust slipping away at superluminal speed. But the rule and the observation live together comfortably once you change the frame. Galaxies aren't racing across a fixed floor. The floor itself is lengthening beneath their feet. No law forbids space from expanding quickly. Relativity only restrains motion through space, not the swelling of space itself. Picture a rubber sheet sprinkled with dots. Pull the edges so the sheet stretches evenly. The dots grow farther apart, though none of them creep across the surface. Or imagine you and a friend on a long treadmill. You walk toward one another, but the belt carries you apart. In the universe, light is the walker. Expanding space is the belt. In some far-off regions, the belt speed, the rate at which space stretches, outpaces light's stride, and no signal closes the distance. This isn't a loophole, it's a distinction. Relativity's speed limit governs objects surfing the fabric, not the way the fabric itself may change. And change it did, dramatically, in the universe's first heartbeat. There was a brief and astonishing episode called inflation, when space grew at an explosive rate far faster than light could have raced across it. In far less than a blink of our time, the universe dilated from subatomic smallness to macroscopic size. That surge did not violate any rule. It was space itself swelling, not particles blasting through it. Inflation smoothed the early cosmos, ironing wrinkles until the fabric was nearly uniform, while planting faint seeds, tiny differences in density that later gravity would amplify into galaxies, clusters, and the webbed architecture of the night. It also explains why the universe looks so similar in every direction, even where regions could never have exchanged messages once the expansion settled. Everything was once close enough to agree, then was whisked gently apart. The imprint of that early smoothing remains. We see it in the almost even glow of the cosmic microwave background, the afterlight of the young universe, cooled and stretched into microwaves, still bathing us from all sides. We sense it in the large-scale uniformity of galaxy distributions and in the delicate ripples etched across the sky. Inflation gave the cosmos its quietness, and its structure a paradoxical gift, serenity born from swift expansion. Even now, so long after that first surge, we live with similar consequences. The universe continues to grow. The farthest reaches retreat so quickly that their new light will never arrive. Some of the galaxies we admire through our best instruments have already crossed that boundary. We see them because the photons they launched long ago are still on the way, still finding us like faithful postcards. But the messages they send today will be swept backward by the river's current, forever unable to make the crossing. It's like catching the last red gleam of taillights disappearing around a bend. The glow reaches you, clear and certain, but the car itself is already down another road. What you hold is the memory of passage, not the presence. There's a soft melancholy in that stories continuing beyond our hearing, stars living out their arcs past our horizon, whole galaxies conducting their quiet affairs in a distance that deepens with time. The melancholy is gentle, though, and it is paired with wonder, because for all that slips away, so much still arrives. Ancient light finds us nightly, brushing your eyes with news from eras before our planet learned to breathe. We count the faintest glimmers, measure their colors, decode their stretch, and from those whispers, we reconstruct a history so vast it feels like weather. Patterns laid over ages, change settling in like a season. Hubble's widening told us how to play the film backward. The supernovae of the 1,990 seconds taught us that the film's pace is increasing. Inflation explained why the first frames look so smooth, why the noise is low, why the seeds of structure are the sizes they are. Together, these ideas knit a picture that is both solid and soft. A universe that follows rules beautiful enough to lull you, but generous enough to surprise you when you least expect it. And still, the expansion doesn't touch everything the same way. Gravity keeps its reliquaries intact, galaxies bound in their halos, stars circling their centers, planets obedient in their lanes. Electromagnetism ties atoms, builds molecules, holds the mug to your palm. On these scales, the cosmic tide is a rumor you never hear, Only when you look across gulfs between clusters does the hush grow audible, a faint, steady widening, like breath. If you close your eyes, you can imagine the whole of it as a room that is very slowly growing, warmer and larger, beams easing outward, walls stepping back a fraction each hour. Nothing rattles. Nothing breaks. The furniture stays where it should. The lamp still casts its pool of light, and somewhere far beyond the house, the landscape very gently shifts. When you open your eyes, the stars have moved apart by less than a whisper, but the arithmetic of space has changed. This arithmetic lets galaxies recede faster than light, not because they are reckless, but because the ruler between them is lengthening more quickly than light can measure. It sets horizons that are kinder than walls and more honest than promises. It smooths the early universe and accelerates the late. It keeps faith with relativity while stretching our intuition thin enough to see through. And in the midst of it, you, a small life under an old sky, hearing the past arrive in the present, feeling the present slip gracefully into the future. On some nights you might sense the distance in your bones, the way everything is connected and yet gently parting. On others, you might simply enjoy the quiet certainty that change can be slow, steady, beautiful, for all the mystery. There is a practical mercy that comes with understanding, knowing that space isn't pushing your coffee cup away, that your home galaxy is safe within its own gravity, that expansion's touch is felt only across unimaginable distances. These are reassuring truths, knowing, too, that what races beyond our horizon does so without malice, simply following the same calm equations that cradle you here, is its own kind of comfort. And so we keep listening. We build better mirrors and colder detectors and wider eyes. We time the brightening of distant supernovae, weigh the geometry of space with galaxy surveys, watch the faint polarization of ancient light for hints of the first inflationary waves. Each new instrument is just a deeper breath, a softer ear pressed against the cosmic door. Meanwhile, the dough rises. More photons finish their journeys and tap our windows. New distances lengthen beyond reach. The universe writes its long epilogue with patience, sentence by sentence, line by line. A story whose ending is not a closing but a widening into quiet. We read what arrives, accept what never will, and allow both to be beautiful. Somewhere beyond what we can see, there are galaxies we will never know by their present light, stars we will never count, worlds we will never imagine. They are not lost to us through neglect or failure, but because the road between us is a river flowing outward, swift and sure. We remain lucky travelers to have met so much of the past, to have caught so many messages mid-flight, to have learned to hear an expanding cosmos as lullaby rather than alarm. And if the universe has a sense of humor, maybe it is this. The faster it grows, the more gently it tells its story. The more it slips from our future, the more of its history it lays at our feet. We are small, yes, but we are also precisely placed on a warm little rock, under a sky of patient light, quietly counting the glow while the fabric beneath us rises like bread in an oven, fragrant with time. Our minds like tidy rooms with corners, so we often imagine the universe as a giant black box, a ceiling, a floor, 4 clean walls, and maybe a sleepy guard posted at the edge. But space doesn't come with trim and molding. Its shape is subtler, quieter, and more interesting than any box our furniture would fit in. Space can bend, it can curve, and that gentle curvature doesn't just decorate the cosmos, it guides how light travels, how structure forms, and how the future unfolds. Start with 3 simple possibilities. If space is flat, it behaves the way your school geometry promised. Parallel lines stay parallel. Triangles add to 180 degrees. A straight path never loops you home. It just carries you farther into a horizon that keeps stepping back. If space is closed, it has positive curvature, like the 3-dimensional cousin of a sphere. Parallels eventually meet. Triangles sum to more than 180 degrees. And a perfectly straight journey would, after inconceivably long wandering, return you to your starting point. If space is open, it has negative curvature, saddle-shaped. Parallels drift apart. Triangles add to less than 180 degrees, and a straight path never curves back. It carries you outward forever. These aren't matters of taste. They're consequences of content. Matter and energy set the geometry. Cosmologists compare the actual density of the universe with a special benchmark called the critical density, the amount that would make space perfectly flat, more than critical. And space is closed. Less, and it's open. Just right, and it's flat. It's the Goldilocks problem, but measured in gravity rather than porridge. How do we measure a curve too large to see? The universe left us a baby picture, the cosmic microwave background, a faint afterglow from the hot, early cosmos. That glow is not perfectly smooth. It carries tiny ripples, fossil sound waves, imprinted on the sky. By reading the typical angular size of those ripples, we learn how space bends light over vast distances. If the cosmos were strongly closed, the ripples would look a little larger. If strongly open, a little smaller. Observations tell a remarkably simple story. To the limits of our best instruments, space appears very close to flat. If there is curvature, it's gentle enough to hide beyond our present sensitivity, like a tabletop that might curve somewhere past the far wall, but not within the room we can see. Flat doesn't automatically mean infinite, and curved doesn't automatically mean finite with an edge. Geometry and topology, the way space connects to itself, are related, but not identical. A flat universe can be infinite, like an endless plane, or finite, but edgeless, if it wraps around into a 3-dimensional torus. Imagine a cosmic donut with no boundaries. A closed universe can also be finite and edgeless, like the surface of Earth, scaled up a dimension. You can travel forever without finding a rim. The phrase, finite but unbounded, sounds contradictory until you stand on a globe and notice the ocean never ends in a cliff. Could we ever catch space looping on itself? In principle, a wrapped universe might produce repeated patterns, mirrored patches of sky, or matched circles in the CMB where light has lapped around. Astronomers have searched for such echoes. So far, no convincing repetitions have appeared. That doesn't rule out clever topologies. It may simply mean that if space wraps, the loop is larger than the bubble we can observe, or oriented in ways that hide from our keyhole view. Even perfect instruments would face a gentler limit: time. We only see as far as light has had years to reach us. If curvature is extraordinarily mild, even a photon traveling for billions of years won't reveal it. It's like standing in a meadow trying to prove Earth is round. The grass seems flat because your walk is short. On cosmic scales, we haven't circled the field. Curvature doesn't just shape maps, it nudges destiny. Before dark energy entered the story, textbooks often claimed closed universes eventually recollapse. Open and flat universes expand forever. With dark energy, a gentle pressure in the fabric of space that accelerates expansion, the script changes. Today's measurements suggest the universe will keep expanding, regardless of a whisper of curvature. A grand, big crunch seems unlikely. A long, quiet fade appears favored, though the details depend on what dark energy truly is and whether it stays constant. To feel curvature, step down a dimension. Imagine living on the skin of a balloon. You cannot burrow beneath or hover above. Your world is the two-dimensional surface. Draw a triangle using the equator and lines of longitude. Its angles add to more than 180 degrees. Walk straight, following the geodesic, the straightest possible path on the surface, and after a very long journey you return to where you began, without ever turning around. No edges, no walls, only continuity. Now imagine a saddle. Triangles there add to less than 180 degrees, and straight paths never close. Lift those ideas into 3 dimensions, and you have, in spirit, the closed and open spatial geometries we test against the sky. There's another kind of bending, local curvature caused by matter and energy right where they sit. A star or galaxy cluster dents space-time so that nearby paths tilt toward it, not because it pulls with a mysterious force, but because the straight lines are curved there. Light passing such a mass is deflected. Distant galaxies appear stretched or duplicated. This is gravitational lensing. It's not the global shape of the universe. It's the local sculpting of its fabric. A nearly flat cosmos can be richly lensed, the way a level field can still ripple with hills and streams. To read the global shape, we rely on cosmic yardsticks. The early universe sound waves left a preferred length. The sound horizon first etched in the CMB, later echoed in the clustering of galaxies as baryon acoustic oscillations. Compare that known scale to how large it appears across the sky, and you learn how space bends. It's like holding a ruler at arm's length. If the room distorts the view, the tick marks betray it. The tick marks whisper, nearly flat. If space is truly infinite and fairly uniform, arithmetic gets dreamy. With endless rolls of the cosmic dice, patterns repeat somewhere. Not metaphysical necessity, just math sprawling without end. In such a universe, there could be regions eerily similar to ours, and others where one star or one sentence differs. It's a lullaby idea rather than a firm conclusion. Whether the universe is infinite or simply very large remains beyond our horizon's authority to pronounce. Even without infinity, edges evaporate in edgeless spaces. There is no rim where space quits and other begins. There is only the fabric continuing without borders, or returning to itself in a loop too vast to walk. We don't stand at a ledge. We drift inside a geometry that keeps its promises softly. Geometry used to be cast as fate, closed for crunch, open for forever. Today, dark energy conducts the rhythm. With expansion accelerating, the large-scale future looks like unending outwardness. Gravity keeps local islands intact, stars circling their cores, galaxies bound by halos, even as the gulfs between clusters widen. Over immense times, starlight will thin, new stars will form more slowly, and the night will mute. None of this asks us to hurry. On human scales, the cosmos is unhurried beyond measure. The curve of space is not a cliff to fear, but a room to rest within. If you want a handhold, return to the balloon. You are a tiny traveler on its skin, setting out under a sky of painted points. You walk the straightest path your world allows. Much later, a familiar hill rises, though you never turned. The world itself curved you gently back. Now trade the balloon for a universe. Your straightest lines, geodesics through three-dimensional space, may, in some global geometries, bring you home after unimaginable ages, or they may carry you outward forever in an open saddle, or never quite circle in a flat, edgeless expanse. Each option is coherent. Each is beautiful. A few practical notes hide in the poetry. When you hear that the universe appears close to flat, think of a table that runs beyond the house level to every spirit level you own, perhaps curving only in distances no carpenter could test. When you hear finite but unbounded, think of Earth's surface, a total area you could, in principle, measure, without a cliff anywhere. When you hear that topology might wrap space on itself, imagine a hall of mirrors configured so cleverly that the copies sit beyond the hall you can walk today. And when you hear that curvature affects the fate of everything, remember the quiet third player, dark energy. It dilutes the old rulebook and favors an outward drift that never stops. In that story, the night grows wider. Island universes keep their small harbors a while longer, and the last bright pages are read softly. It's not a tragic ending, just a slow one. A universe writing itself into calm. Whatever the shape, you are woven into it. The atoms of your breath arrange themselves according to this geometry. The light leaving your room fans into geodesics the universe provides. Even your thoughts' brief ripples in neural fields are excitations of matter whose rules trace back to the fabric you're trying to imagine. We do not merely live in space, in a small, tender way. We are space, momentarily arranged into awareness. So stand at the window for a moment. The sky above you is not a ceiling. It's the inside of something vast and possibly edgeless. If the universe is flat, you walk a grand plane of possibility. If it's closed, you stroll inside a loop large enough to feel like forever. If it's open, you glide a saddle into the endless dark. None of these shapes requires a wall to be real. None needs a border patrol to be true. Each is simply a different cadence in the same lullaby, a geometry you can't quite see, but can learn to feel the way you feel the curve of Earth by the slow return of seasons. And if all this seems abstract, let the math rest and listen instead. Triangles whisper their sums. Parallel lines confide whether they meet. Ancient ripples hum in the background, glow. The universe tells you its shape by how it lets light arrive. Your part is easy. Breathe, look gently, and let the story curve around you. However space bends, you belong to its bend. Picture the idea again, but let it breathe wider. Not just a creature walking along a rubber skin, but all of us living within the skin itself. A three-dimensional world whose shape we feel more than we see. Imagine the universe as a 3D counterpart of that balloon surface. It doesn't need to bend into some larger room you could point at. It can curve by its own rules from the inside. We move through that interior, never glimpsing any outside, much like the little balloon dweller has no sense of the air beyond the latex. In this gentle model, galaxies are the inked dots. As the balloon inflates, the dots drift apart, not because they crawl over the surface, but because the surface stretches underneath them. That is what expansion means. The distance grows because space grows. Galaxies are passengers more than travelers. The road itself is lengthening between the towns. If the fabric truly carries a global curve, and the total space is finite, a quiet consequence follows. Walking the straightest path long enough could bring you home without a single turn. There is no cliff at the edge, no edge at all. The loop closes softly. A universe can be limited in total size, yet lack any boundary, letting you wander forever through a finite whole, always moving, never running out of room. The same picture explains why there is no favored center to the expansion. On the balloon, every point sees all other points receding as the skin swells. None sits on a throne. In our universe, you may choose any place and call it here. And on large scales, the view is broadly the same in every direction. Expansion is not a burst from a single spot. It is a change that happens everywhere at once. Still, the balloon is only a helpful ladder, not the roof itself. Its skin is a two-dimensional surface sitting inside a three-dimensional space we can see and touch. Real cosmic curvature does not require any larger container. Space can be curved intrinsically by its own metric without bowing into an outside. That is one of Einstein's quiet insights. Space-time isn't a passive backdrop holding the play. It's an actor with lines of its own. Mass and energy tell space-time how to curve. Curved, space-time tells matter how to move. The conversation never stops. And from it come the orbits of planets, the dance of galaxies, even the tides of starlight. Light follows those rules faithfully. And a perfectly flat emptiness. Straight is easy to picture. In curved space, the straightest possible route a geodesic may arc, much like the great circles that girdle a globe. In our universe, that path is shaped both by any large-scale curvature and by local dents where matter gathers. This is why massive objects bend light, and why galaxy clusters can act like lenses. A distant galaxy may appear, stretched into an arc, mirrored, or ringed around a cluster, as though you were peering through a slow, truthful funhouse mirror. The distortions are not errors. They are measurements written in the language of curvature. So when you look up at night, you're not seeing lanterns pinned to a flat ceiling. You're watching a web of light traveling along the fabric's lines, nudged here by a star, bowed there by a cluster, quietly redrawn by the geometry beneath it. The sky's beauty carries information. Every gentle skew tells you something real about the shape of the room you inhabit. Return to the balloon once more for a small but important detail. While distances between dots grow, the dots themselves do not swell. The ink remains the ink. Likewise, expansion does not pry apart what gravity or other forces already hold together. The Milky Way keeps its spiral. The solar system keeps its lanes. Your cup does not creep away from your hand. Expansion takes hold in the great emptiness between unbound structures, where gravity loosens and the fabric is free to lengthen. As for what urges the lengthening onward and even quickens it, we give it a modest name: dark energy. It behaves like an energy woven into space itself, a pressure that coaxes the large-scale distances to grow faster with time. We don't yet know its deeper nature, but we see its signature in the way distant galaxies recede and in how ancient light spreads and fades. It is as if the balloon is not merely inflating, but inflating a little faster with every breath. Where does that leave us? In a home that may be curved from within, possibly finite yet boundless, expanding yet centerless, a place whose rules can feel alien to everyday life and perfectly natural at cosmic scales. The same fabric that lets galaxies drift apart also cradles planets in their orbits. The same geometry that bends a beam of light also lets that light reach you across astonishing time, still carrying the memory of where it began. You can hold this world in mind with a single, humble image: a balloon, not because the universe floats inside an even larger space, but because the balloon gently illustrates the things we most need to feel, that distances can grow without anyone moving through space, that there is no special center, that a finite realm can lack an edge, and that straight can be curved when straight belongs to the surface. If your thoughts reach for more, remember intrinsic curvature. No outside is required. The rules live inside the room. We test them not with guesses, but with light itself, with the arcs and rings carved by lensing, with the slow shift of colors called redshift, with the patterns in the universe's faint afterglow. All of it points to a fabric with shape and stretch, a fabric that evolves. And if the thought of traveling a straight line that eventually returns you to your starting place makes you smile, let it. In some geometries, that's exactly what straight would do. In others, your path would never close. Either way, there is no border to collide with, no edge to fall from. There is only the road the fabric provides and the patience to walk it. So when a balloon slips loose and climbs into the evening, give it a small nod. Beneath its bright skin is a lesson, a surface that needs no outside to curve, a stretch that belongs to the surface itself, a shape that can be complete without a rim. Our universe may be like that, only richer by a dimension, and written in the grammar of space-time. The place you are heading could, in a quiet, cosmic sense, be the place you began. Only now, the journey itself has changed you, and the fabric that carried you has widened while you walked. Infinity. The word feels like it ought to keep going after you say it. A syllable that never quite lands, a breath that lengthens into silence. It suggests star fields without borders, horizons that don't curve back, and equations that stretch so far they become a kind of poetry. When we ask whether the universe is infinite, we're really asking whether space itself ever stops, whether there's a final wall, or whether the hallway simply keeps extending into night. Or perhaps, more quietly, we're asking if edge is even the right idea. What we can say with care is this: everything we've measured on the largest scales points to a cosmos that is very nearly flat. Ancient light, the cosmic microwave background, that soft afterglow from the universe's hot youth, carries ripples whose patterns tell us how space bends. Those ripples look the way they should if geometry is flat to a remarkable degree, not bulging like a sphere and not bowed like a saddle. In general relativity, a flat universe can be infinite. If not infinite, it is at least vastly larger than the piece we can see. Our visible piece, our observable universe, spans about 93 billion light-years across, defined not by walls, but by time, the farthest distance from which light has had enough years to reach us. Beyond that bubble, the story may go on and on. We don't see an edge. We simply run out of signals. We live with that limit the way beach-dwelling ants live with the horizon. Everywhere they look, there is sand. They can't know from their small vantage whether the shoreline ends 10 dunes away beside a tide pool or whether it crosses a continent. They can only describe the patch they've walked. Our telescopes, as heroic as they are, remain ants' eyes on an enormous beach. Infinity isn't something we measure, like the distance to the moon. There's no cosmic ruler we can lay down until numbers stop. Infinity is not a number. It's a concept, a shape of possibility. And science, faithful to evidence, approaches concepts obliquely. We don't observe infinity itself. We look for signs that space shows no sign of folding back on itself, no sudden boundary, no repeating pattern that would give the loop away. So far, in every direction, we find no fence. There is no drop-off, no rim scrawled with a do not pass warning, only a steady wash of galaxies and the slow reddening of their light. That doesn't prove infinity. It only says that if the universe does curve back or close on itself, it does so beyond our horizon, or so gently that billions of years of light haven't noticed. And unless we somehow build an instrument that outruns both light and the expansion of space, a tool the laws of nature do not seem inclined to offer, the horizon will remain a horizon. It's beyond, still beyond. If space is truly infinite, certain consequences arrive with a hush and then a thrill. An infinite stage invites an unbounded cast. Stars upon stars, galaxies upon galaxies, uncountable worlds. If matter is distributed roughly uniformly, probability begins to weave peculiar tapestries. Given limitless rolls of the cosmic dice, patterns recur. The familiar appears in faraway rooms. Somewhere, unimaginably distant, there may be planets that rhyme with ours, seas that glitter with unfamiliar colors, forests with leaves that turn on different winds. Stretch the arithmetic further, and the idea gets stranger. In an infinite, uniform universe, arrangements eventually repeat. There could be regions where the broad strokes match our own histories that rhyme, faces that look back like echoes, not next door, not across any span we could traverse, but out beyond reach forever, their light eternally outpaced by the universe's growth. You will not meet your cosmic double at the grocery store, yet the thought shifts something inside. Infinity turns large into boundless, and elsewhere into a word too small for what might be. There is virtue in caution. Infinity should be held with an open hand. Our entire argument rests on a local view, a finite sample of a possibly boundless quilt. Cosmologists keep gently in mind that space could be very large yet finite, curving lightly back on itself in ways our measurements haven't yet pinned down, perhaps looping through topologies more subtle than we've imagined. A universe can be nearly flat, where we can see and still close on itself beyond our sight. If so, the map would have no edge and still be complete, like a globe that looks flat on a picnic blanket. And even if space itself were endless, time may not be. Our cosmos has a history, a beginning of sorts, an era before which the patterns we call universe had not yet taken the shape we recognize. Endless extent and finite duration are not contradictions. Infinity also asks something of us, philosophically. Our days are made of limits. We carry finite hours and finite energy. Even the cookie jar empties eventually. Infinity, by contrast, is a refusal to end, a canvas sprawling past any frame. Some ancient thinkers mistrusted it not out of meanness, but because genuine infinities felt too strange to admit into the physical world. Others accepted infinity as an idea, useful in thought, but suspect in nature. The debate hasn't really ended. It has become gentler, wrapped now in observations and models instead of pronouncements. What remains constant is the effect on the spirit. To contemplate infinity is to let one's sense of scale loosen and lengthen. It invites humility. It encourages a soft awe. It reminds us we peer from a local porch, watching a small patch of sky, while the house around us may have more rooms than we can name. Edges tug at us for simpler reasons. We grow up with them. Every hallway ends, every lunchbox closes, every field has a fence, so the idea of a universe without a rim can feel slippery, like a trick of language. But space doesn't need an edge to be real, and it doesn't need an outside to be complete. It can be finite and edgeless at once. The surface of Earth makes the point in 2 dimensions. Walk in any direction long enough and you return to where you started. There is no cliff labeled end of world. The area is finite. You can, in principle, measure it, yet there is no boundary. Lift that idea into 3 dimensions and you can picture a volume that is finite and unbounded. Travel straight inside such a space, and after unimaginable distance, you might come home without ever turning around. No wall, no border post, just continuity. There are ways to visualize this without trapping the universe in pastry, though pastry helps. The surface of a donut, a torus, loops in 2 independent directions. An ant walking along it can stroll forever without encountering an edge, yet the total surface area is finite. Now imagine a 3-dimensional analog, a space that wraps in multiple directions. Your path could carry you across the universe, only to return to where you began. A journey whose straightness is defined not by rails in an external room, but by the geometry inside. In games we've played old screens, where leaving the right edge re-enters from the left. You've already met this idea in 2 dimensions. The map is finite, the edges connect. There are cosmological models that give space such a topology, a way of stitching itself so that far-flung points are, in a global sense, neighbors. If the universe were small enough and wrapped just so, we might even catch repeated patterns in the ancient afterglow-matched circles on the sky, like wallpaper seams from the Big Bang. We've looked. We haven't found convincing repetitions. That doesn't close the book. It only says that if the universe loops, the loop is larger than our visible sphere, or hides in arrangements we haven't teased apart. The deeper truth is simple and patient. Space is not a thing that sits inside a larger thing. It is the thing. It does not need a container any more than a melody needs a box. Curvature is not a bend into an unseen room. It is a property of the room itself. When we say the universe has no edge, we aren't proposing a trick. We're describing the geometry whose completeness doesn't require a fence. And if the universe is infinite, the absence of edge isn't even a question. Infinity doesn't have an endpoint to guard. It is not somewhere you can stand and look beyond. It is a way reality might be. If the mind still longs for a grip, return to the observable bubble. Its radius is not a measure of the universe's size. It is a measure of how long light has had to reach us. The bubble grows as more photons complete their journey. Yet the expansion of space means that some regions recede so swiftly that any new light they emit will never arrive. Our bubble is both a gift and a boundary, a sphere of received messages floating in a sea of messages that will never be delivered. Infinity, if it is the case, lives beyond that sea, unseen, unfelt, inferred only through the absence of a sign that says otherwise. Consider what it would mean for meaning. An infinite universe turns what lies beyond into a softer question. More of the same, perhaps more stars, more dark swaths, more accidents and symmetries, or else more of something we have not yet imagined. A finite but unbounded universe trades what is the edge for how does it close, and offers the possibility of a homecoming that isn't a turn, but a circle written into space. Either way, the lesson is kind. We are already inside what we seek. We are woven into the fabric we are trying to comprehend. We are not standing outside the mansion, looking in through the last window. We are one window among many. Our seeing is local. Our belonging is not. There are other gentle consequences. If space is infinite and roughly uniform, then our patch of it, this arrangement of galaxies, this filigree of voids and filaments, is one of uncountably many. Probability spreads out and fills the canvas. Rare events have room to happen. Long odds find a place, somewhere. A spiral, like the Milky Way, spins with a slightly different arch. Elsewhere, a cluster collapses a little earlier. In another region, a star like the Sun warms a world whose oceans carry colors unknown to our eyes. The scale doesn't trivialize our corner. It enfranchises others. It says that the universe is generous with variety. That possibility doesn't huddle in one small room. Perhaps the most soothing part is that you don't need an answer to live well inside the question. The universe's size, finite or infinite, does not alter the breath in your lungs or the warmth of a hand in yours. It doesn't diminish the light that left a star millions of years ago and found you tonight. We can gather evidence. We can refine maps. We can keep listening for the faintest echoes on the oldest light. All the while, we can rest in the knowledge that mystery is not a failure, but a feature. Infinity, whether real or not, teaches a way of looking, patient, wide, and kind. If the thought of an edge still won't let go, picture walking north from your door, then east, then south, then west, and arriving back home with no cliff behind you and no signpost announcing the end. That is unboundedness. If the thought of an infinity makes you dizzy, picture the night as an ocean that extends beyond sight, not because the ship is magic, but because seas are large. You can sail a long time, learn the currents, chart the stars, and still accept that there are waters you will never cross. Both pictures hold peace. Both let you look up without needing to finish the map. There is an old comfort in all this. Space does not expand into something else. It expands within itself. It does not hide an outside. It provides an inside rich enough to hold galaxies and questions and the quiet of a sleeping room. Whether the universe continues forever or closes softly on itself, whether patterns repeat in unreachable halls or never repeat at all, you are not separate from it. You are a brief arrangement of its fields and particles, thinking about its size. You are a local flicker on the edge of the observable, lit by photons that began their trek before your world had names. You are, for a little while, a place where the universe knows it is being wondered about. So let the word linger. Infinity. Let it lengthen the horizon instead of hardening it. Let it be a way to breathe rather than a challenge to win. Maybe the universe is infinite. Maybe it is not. Either way, it is already more than enough. Enough to carry our science and our stories. Enough to cradle our sleep. And if, someday, you find yourself walking a straight path that somehow brings you home, you'll know that edges were never the point. The journey was. The fabric held, and the room, whether endless or cleverly closed, was always, quietly, yours. Edges make tidy sense to our hands and eyes. The rim of a table, the fence at the end of a yard, the place where water meets air. But when you try to put an edge on the universe, the idea slips. If there were a border, what would sit beyond it? More space to cross, some different kind of outside, or a blank, nothing that somehow is by being not. The moment you draw that boundary, you invite a paradox. If there's something beyond, then space hasn't ended at all. And if there's truly nothing beyond, not even a fabric to stand on or a direction to point, what does beyond mean? The question dissolves under its own weight. An edgeless universe sidesteps this tangle. It simply is a fabric that either stretches without closing or curls back softly upon itself so you can walk forever without meeting a wall. No cliff to sail off. No sign that says stop. Nothing outside that needs naming. You go on, and what you find is more road. Sometimes new, sometimes, in certain geometries, a long, slow circle that eventually returns you home. Still, the urge to ask for borders doesn't disappear. Our minds are trained by containers and calendars, beginnings, middles, ends, lids, and labels. The universe seems not to care for filing systems. It stretches, it curves, it may even loop, and it does so without volunteering. A clean edge we can underline. Even so, there is one kind of boundary that keeps its quiet authority. Time. From our vantage, the cosmos had a beginning. The Big Bang is not a place in space where you could plant a flag. It is a moment, a page where the story starts in hot density and then begins to relax. Asking what came before that moment is like asking what lies north of the North Pole. It's not a foolish question. It's a clue that our usual coordinates lose their meaning at the very edge of their map. So the universe is less like a box with a lid than a melody moving forward. Not a tune with a single final chord, but a theme that varies, weaves, returns, and continues. Borders make little sense to music. Relationships do. Gravity holds dancers in spirals. Light carries memory. Motion writes time, and the fabric keeps time for them all. In such a world, the thought experiment of a spaceship sent to find the edge becomes a gentler story. A long, quiet crossing that never arrives at a cliff, only at new starfields, new questions, the slow widening of night. Not because the universe must be infinite, but because edges were never part of the plan. Before stars flickered or galaxies learned their shapes, before even simple atoms settled down, the universe wore a different kind of light. Imagine a warm, even glow. Not glaring, not spotlit, more like dawn passing through thin curtains. The whole sky was that glow. It came from everywhere at once and went everywhere at once, because everywhere was still pressed close to everywhere else. That light has not gone out. It is only cooled and stretched with the fabric, dimming from a searing brightness to a soft, microwave whisper that still washes through your room right now. We call it the cosmic microwave background, the CMB, the oldest light anyone can see, still arriving after almost the entire age of the universe. To understand why it exists, drift back to the beginning. The universe began hot and dense, its contents jammed so tightly that light could not travel freely. Photons, the quanta of light, ricocheted from charged particles like glitter in a storm, scattering and rescattering before they could go anywhere. The cosmos was a bright fog, energetic, churning, opaque. As space expanded, that fog cooled, temperature fell. Not all at once, but steadily. The way water taken off the stove forgets its boil. About 380,000 years after the beginning, a heartbeat by cosmic standards, protons and electrons finally found it cool enough to bind into neutral hydrogen. That moment carries a soft name, recombination, and at recombination, the fog lifted. With most of the charges tucked into atoms, photons were no longer trapped. They were released into the open, free to travel, and they have been traveling ever since. Those freed photons are the CMB. They left an infant universe, blazing in ultraviolet. Time and expansion stretched their wavelengths down through visible light, past infrared into microwaves, turning a roar into a hush that fills all directions. If your eyes could tune to those wavelengths, the night would never be dark. It would be gently and uniformly lit. We first stumbled upon that hush by accident. In the 1,960 seconds, Arno Penzias and Robert Wilson were using a horn-shaped antenna to study radio signals. Wherever they pointed, a faint, steady noise remained, a warmth that wouldn't go away. They cleaned the hardware, chased down interference, even coaxed some uninvited pigeons from the instrument and tidied what the birds left behind. The noise persisted. Only later did the meaning crystallize. Their antenna had been listening to the oldest light in the universe, the predicted afterglow of the hot beginning, still arriving with remarkable uniformity from every corner of the sky. The hiss was history. Since then, we have mapped that glow with exquisite care. The Kobe mission confirmed its whispering warmth and first revealed tiny variations. WMAP sharpened the picture. The Planck satellite refined it further, giving us a high-resolution portrait of the universe as a newborn less than 500,000 years old. At arm's length, the CMB is astonishingly even. Its temperature is nearly the same in every direction, but when you lean closer, microscopic differences appear subtle, warm, and cool spots only a few millionths of a degree apart. Those ripples are not flaws, they are seeds. Slightly denser places would, over eons, fall a little more, gather a little more, until the first stars kindled, the first galaxies spun, and the first long filaments of structure stretched across the dark. In this way, the CMB is both lullaby and blueprint. It tells us that the early universe was calm enough to be described simply and structured enough to grow complexity. It lets us weigh the cosmos, ingredient by ingredient, by reading how those small variations spread across scales. It even lets us take the measure of space itself. Different global geometries positively curved like a sphere, negatively curved like a saddle, or very nearly flat alter how those ripples look across the sky. When we compare the characteristic size of the patterns to the size predicted by physics of the early plasma, we find that the patterns sit where a flat geometry would place them. Within our observational reach, the room is level. If there is a bend, it's subtle beyond today's sensitivity, perhaps present, perhaps not, but not strong enough to reveal itself in the ripple's arrangement. The CMB also records the universe's expansion history. As the fabric stretched, it cooled that light and shifted it to longer wavelengths. The exact spectrum we measure today is a near-perfect blackbody curve, the thermal fingerprint of a once hot glow, now at about 2.7 Kelvin above absolute zero. That perfection is its own comfort. It tells us the universe expanded and thinned in a way that preserved the glow's thermostat, smoothing out local quirks into a global consistency. Layered atop that smoothness sit the tiny variations, and within them we read the handiwork of gravity, the influence of ordinary matter, the trace of dark matter scaffolding that guided collapse, and the quiet push of dark energy that later began to accelerate the expansion. Even the idea of edges finds a gentler answer in this light. We do not need to chase a border to learn about beginnings. The beginning is already here, bathing us in photons that launched when space became transparent. Every time we measure the CMB, we are sampling the universe's first clear view of itself. It is the closest thing to a baby photograph the cosmos owns. Not posed, not framed, just an honest snapshot of how things looked when light first slipped its leash. If you could hold a special radio to your ear, the CMB would not sing. It would murmur, a soft static, a constant warmth, present in all directions. That constancy is soothing. It tells you that even in the vastness, there is a single story knitting the sky together. The light that touches you tonight left regions now unimaginably distant, some so far that any new light they emit will never arrive, swept backward by the expansion's steady current. Yet their earlier light is here, which means the past keeps stepping into the present, quietly, as if to say, you do not need an edge to belong to a whole. You can even think of the CMB as a map drawn not with lines and borders, but with relationships. The slight excess here and the slight deficit there encode how matter gathered, how pressure waves moved through the primordial plasma, how gravity tugged, how light responded. From that map, we infer our universe's curvature to the limits of our sight. From it, we extract the ratios of ordinary matter to dark matter and the imprint of a cosmological constant like pressure. From it, we learn that flat is a good first answer to a deep geometric question. The CMB doesn't show you a wall. It shows you a pattern that only makes sense in a room without one, all of which circles gently back to edges. An edge asks us to define a beyond. The CMB asks us to listen to a within. We are not peering over a parapet into a void. We are bathing in the light of our own early days. When you look up on a clear night, the stars you see sparkle against black, but that black is not empty. It's saturated with a 14 billion-year-old glow, cooled into invisibility to your eyes, but waiting in wavelengths our instruments can hear. The universe has carried that light across epochs, through births and deaths of stars, past uncountable worlds, into the moment where you sit and breathe. So, if the mind keeps returning to the edge, to the cliff, a brave ship might find, let it rest on this instead. There is no need for a cliff. The universe opens like an idea, not closes like a room. Time gave us a beginning to measure. Space declines to offer a boundary to label, and in the quiet where those truths overlap, the oldest light continues to arrive. A steady, patient presence that proves you live inside the story you're trying to understand. You are not outside looking in. You are inside, listening, while the first light keeps whispering its uncomplicated news. The fog lifted, the fabric stretched, patterns formed, and from those patterns came stars, and from one of those stars, a small world, and on that world, a person wondering how far things go. Edges may frame our furniture. They need not frame the cosmos. The universe does not stop. It changes key, and beneath that change, the CMB hums on, the same in all directions, the oldest note you can hear. Is there a final curtain, a last, thin wall where space simply refuses to continue? The question keeps returning like a tide. We whisper it between chalkboards and telescope domes. We tuck it into science fiction and then carry it softly back into physics. The standard picture of the cosmos leans away from hard edges. Space seems to stretch or loop without presenting a rim to run into. And yet, when we let our thoughts drift a little farther, stranger doors open. Not doors to a cliff or a fence, but to ideas in which boundary means something subtler, a limit you can't touch with your hands, but that might still be real in the equations. One such idea imagines our universe not as the whole of what exists, but as a three-dimensional membrane floating within a higher dimensional sea. In this brain picture, most of what we know matter, light, the familiar forces is confined to our membrane, the way a bug is confined to the skin of a soap bubble, gravity is the quiet exception, allowed to spill a little into the bulk around us, which could explain why it feels so gentle compared to the other forces. If this is the true architecture, then edge takes on a new meaning. Not an edge you could ever find by flying long enough, but a boundary in directions we do not perceive, a contour of the brain itself within the larger space that hosts it. From where we sit, everything is continuous. From a hypothetical 5-dimensional vantage, our cosmos might look like a luminous sheet with margins. Another possibility arrives from the early universe, when high energies and symmetry ruled. As the cosmos cooled, those symmetries may have fractured in different ways, in different places, as if reality passed through a series of phase changes like water freezing into ice crystals, but not choosing the same crystal pattern everywhere. Where regions with different choices met, borders could have formed, domain walls, quiet seams across space, separating slightly different versions of the rules. In many models, these walls fade quickly, or their effects dilute until they are harmless whispers. Yet some speculative scenarios let them linger, stretched thin across enormous distances. Crossing one might not be dramatic. The physics on the other side could be only subtly different. A world almost like ours, whose chemistry is shifted by a hair. Tea brews, stars shine, and yet something in the air feels fractionally unfamiliar. There is also the picture of space, beginning as a froth of possibilities. In an inflationary epoch, a moment when the fabric expanded with astonishing speed. In some versions, inflation does not end everywhere at once. Here and there, it stops, and a pocket forms, a bubble universe with its own properties and constants. Elsewhere, inflation continues, spawning more bubbles forever. This is eternal inflation, and it leads naturally to a foam of universes, a multiverse scattered across a larger, inflating background. If we live inside one such bubble, then there is, in a sense, an edge, the place where our bubble gives way to the inflationary outside, or where another bubble might someday brush against us. But the distances are so vast, the expansion so insistent, that a meeting is unlikely beyond measure. If collisions ever occurred, their signatures would be faint and rare. For us, the bubble's rim is less a destination than a boundary condition written into the beginning. Other solutions push the mind sideways. In 1949, Kurt Gödel, the same thinker who showed that even mathematics has limits to what it can prove, found a curiosity tucked inside Einstein's equations, a model of a universe that rotates as a whole. In it, space-time twists in such a way that, along certain paths, you could, in principle, loop back to your own past. No walls, no edges, just a blur at the boundary between cause and effect. Our universe does not appear to share this global spin. The observations don't match, but Gödel's construction matters as a lantern, showing that the space of possibilities allowed by the equations is wider than intuition. It reminds us that what is permitted on paper can be startlingly different from the rooms we live in. A different kind of edge appears when we think about information. The holographic principle whispers that everything happening in our three-dimensional world may be fully described by data living on a more distant, two-dimensional boundary. Not a flickering science fiction projection, but an exact correspondence between volumes and their edges. Black hole physics first delivered the hint. The amount of information a black hole can contain scales with the area of its horizon, not its volume. If that lesson extends to the cosmos, then the deepest border is not a wall you can fly to, but a place where the bookkeeping lives a boundary on which the universe's story is written in a different script. The inside and the boundary would be two faithful translations of the same tale. No fence, just another way to say the same truth. Taken together, these ideas don't promise a cosmic barricade with a warning sign. They propose boundaries of a different kind. Edges in extra dimensions. Edges as seams between regions with slightly different rules. Edges as the frontier where a bubble meets a broader sea. Edges that are not surfaces at all but repositories of information. There may be no wall to find. There may be limits, instead limits, of what we can observe from here, of what light can deliver, of which aspects of reality our current equations can comfortably hold. A boundary of knowledge is still a boundary. It shapes how far we can walk before the path becomes mist. It helps to be kind to our instincts. We learned edges from rooms and rivers, from cliffs, cups, and calendars. We carry those lessons into the sky and look for equivalents. Where does it stop? Why does it stop? What's on the other side? The universe keeps answering with curves and continuations. It loops, it stretches, it offers geodesics that never meet a brink. Even time, which does carry a beginning in our models, places its border differently than our hands expect. The Big Bang is not a dot you can approach. It is a moment past which our familiar language, before, after, where, falters. Asking what came before the beginning is like asking for a step beyond the summit of the North Pole. It's a sign that our compass needs a new kind of north. In that light, a spaceship built to chase the edge becomes a ship designed for a different voyage. It will meet more stars, more darkness, more of the same long fabric, perhaps forever, perhaps until the path curves softly back to where it began. This is not a disappointment. It is an invitation to a quieter kind of awe. The universe doesn't close like a door. It opens like an idea. Edges are not absent from the story. They simply wear other faces. Some are stitched into the initial conditions, the way space began. Some may be written in a hidden topology that returns our straightest lines to themselves. Some are the gentle horizons set by expansion, the limits of what we'll ever receive, no matter how patiently we wait. And one of the most beautiful edges sits all around us as light, the cosmic microwave background, that first clear glow from when the universe became transparent. It proves we do not need to reach a border to touch a beginning. The beginning, cooled and stretched, still touches us. If we listen carefully, a theme emerges. Boundaries in cosmology are not always places. They are sometimes relations. They tell us how regions connect, how rules change, how information is stored, how far cause can travel. They are not ends so much as shapes. We may live in a cosmos with no edge in the way a room has a wall, and yet we will still meet limits of method, of reach, of meaning that ask us to revise our questions and soften our expectations. All of this sits within the universe we can study. Billions of galaxies, a web of dark matter, black holes humming at their cores, light red shifting as the fabric stretches. It is already more than enough to learn from, already more than enough to fill a lifetime of careful nights. And yet, it is also human to glance beyond the lamp and wonder whether even the universe is a local word. If inflation throws bubbles like foam across an unseen sea, if brains float in a larger bulk, if information on a far boundary holds our story, then perhaps what we call everything is itself A room in a larger house? The honest answer, tonight, as on most nights, is gentler than certainty. Maybe space has no edge, only horizons. Maybe there are seams between regions with slightly different songs. Maybe there is a broader melody in which ours is one verse among many. Or maybe the true shape is something we have not yet learned how to imagine, something that curves and connects in ways we will only discover by listening longer to light. For now, we can rest in what we have. A sky that holds messages from the first clear moment. Equations that map curves into motion. Instruments that can hear whispers older than stars. A mind that can be both curious and calm. We can accept that the universe is under no obligation to reproduce our rooms in the sky, and that our longing for edges is a lovely habit we can let go of when the night asks for quiet. And if, after all this, the question still returns, is there an edge? Let it return as a lull, not a demand. The cosmos is not less mysterious for refusing to draw a line. It may be more so, and more merciful. A place where even the questions can keep unfolding. And if, once in a while, we ask the larger question that sits just beyond the last star, what if this universe is not the only one? Then we are only doing what the universe itself seems to do, stretching, connecting, and continuing. Without a signpost to stop us, slip a little deeper into the quiet and let a wide idea drift in beside you. The multiverse. Not a single room, but perhaps a neighborhood of rooms, maybe a whole city, maybe a country without borders. It's one of modern physics' most audacious whispers, that there could be more than one universe, possibly uncountably many, each with its own rules, its own weather of particles and forces, its own long unfolding of time. In one, gravity may lean sideways. In another, chemistry hums in a different key. In a third, your high school haircut somehow turned out beautifully and launched a glorious era. The thought is playful. The implications are not. First, a soft, essential truth. We have no direct evidence of other universes. None. No telescope has waved to a neighboring cosmos. No instrument has caught a postcard sliding between realities. The multiverse is not a measured conclusion. It is a framework that grows naturally out of certain theories. An idea, not a sighting. Still, ideas can be worth holding gently. This one comes in several flavors, each offering a different way of thinking about how everything might be larger than we thought. One version springs from the early rush of expansion called inflation. In that first fraction of a moment after the Big Bang, space may have swelled at a staggering rate, ironing the young universe smooth. But perhaps inflation did not end everywhere at once. Maybe it relaxed here and there, leaving pockets where the frantic growth stopped and ordinary cosmic time took over. Each pocket would be a bubble universe, expanding and evolving on its own, with its own settings for the constants of nature. Some bubbles might be too strange for atoms to settle or stars to ignite. Others might be calm enough to raise galaxies and the occasional curious species whispering questions into the dark. In this bubble picture, we live on one glossy globe in an immense foam, drifting apart from our neighbors so quickly that even light will never carry greetings between us. No interbubble traffic, no rendezvous at the edge, just a distant kinship we can imagine, but not confirm. Another version comes from the quiet strangeness of quantum mechanics. At the smallest scales, nature speaks in probabilities. This outcome with this amplitude, that one with that. One way to make sense of this is to imagine that the universe does not pick a single result and discard the rest. Instead, all outcomes happen, each in its own branch. This is the many worlds interpretation. Every time a quantum event offers a fork, reality splays into paths. In one, you hit snooze and sleep again. In another, you rise before dawn and make pancakes. In another, the pancakes go so sensationally awry that by lunchtime, you've accidentally invented teleportation. You cannot hop between these branches. There is no station where a mustachioed conductor sells tickets to the world where I kept practicing the harmonica and now tour Staples Center. But if many worlds is right, the branching is not fiction. It is the most economical way to keep the mathematics honest, replacing the awkward collapse of a wave with a steady unfolding of possibilities. A third version widens the stage even more. The mathematical multiverse, proposed by Max Tegmark, suggests that any structure that is mathematically consistent exists as a physical reality. If the equations make sense, somewhere they are realized. Not just universes with different constants, but worlds where logic itself plays by different rules, where pi is not the number we know, where time, instead of streaming, curls or lattices or moves in pulses. It's a daring thought, perhaps untestable, perhaps more philosophy than physics, yet strangely calming if you like your cosmos generous. The library of possible realities stands not merely on the shelf, but open. Every book already written. These ideas share a delicate problem. How do you test what you cannot touch? Science loves predictions. It can try to break measurements. It can repeat under a colder sky. If other universes are, by construction, sealed off from ours, no signal in, no signal out, then falsifiability becomes slippery. Some physicists take this as a warning. Perhaps our theories have wandered beyond their useful domain, building castles in thin air. Others answer that even if we cannot travel to a neighboring cosmos, a multiverse might still make honest contact with data. If innumerable universes exist with different settings for the constants, then it is no surprise that we wake in one where the settings allow for chemistry and stars and breath. This is not cheating. It is selection. We are at a table where the dice landed just so, not because we rigged them, but because you only find yourself sitting at tables where life is possible. There are even tentative proposals for how our bubble could, in principle, have bumped another. If two bubble universes once collided, the scar might linger as a subtle pattern in the cosmic microwave background, a faint circular anomaly, a seam in the wallpaper of the oldest light. People have looked. So far, nothing whispers collision in a way we can trust. The sky remains stubbornly ordinary in its extraordinariness, but the search itself is valuable. Many of physics' best surprises began as questions that seemed almost impolite to ask. Whether or not a multiverse exists, contemplating it stretches our field of view. It tells us our local habits, boxes, and borders. One room and no door might not be the only architectural grammar reality knows. It invites humility. Perhaps the values we measure here are not necessary, but contingent. Perhaps our universe is one expression among many ways a cosmos could be. It invites play, too, to imagine other versions of stars and seasons, other histories, other songs, and it keeps our courage in good shape. To stare at a night as large as this and say, I do not know, but I will keep learning, is its own kind of practice. Let the question that started this journey rise again like a soft tide. Where does space stop? After tracing horizons and curvatures, after listening to the hush of the first light and entertaining the possibility of other rooms, we circle back to the beginning, with a slower heartbeat. Space does not behave like a corridor with a cap. It does not require walls to be complete. It can be infinite or finite yet edgeless, looping the way the surface of a globe loops. It can carry galaxies away from one another faster than light without breaking any rules, because it is the ruler that's changing length. It offers us a horizon, not as a border, but as a patience, the farthest distance from which light has had time to arrive. Beyond that, perhaps more of the same, perhaps a gentle fold, perhaps other bubbles we will never meet. Perhaps the multiverse is a faithful map of reality. Perhaps it is a lovely idea that teaches by contrast. Either way, we return to the sky above our own roof with a wider kindness. We know a few steady things. Space is not empty. It hums with fields and the thin warmth of ancient light. It stretches with time. It carries the memories of stars that died before Earth learned its name. It seems to have no center, and as far as our instruments can tell, no end we can point to. And still the important questions remain open like windows. Is the universe infinite or merely enormous? Is its global shape flat, closed, or something our metaphors haven't met? Is this the only verse or one stanza in a longer poem? If there were an edge of any kind, what would it mean to say what lies past it? Not knowing is not a failure. It is the rhythm of science. We build instruments to catch older photons. We fold better mirrors. We polish new equations. We compare notes with the oldest light and the faintest galaxies. We learn to hear the universe more softly. Each measurement brings us closer, and the destination keeps stepping back like a friendly horizon, reminding us to keep our stride. Perhaps that is the right answer for the night. Perhaps space never stops, not because it must be endless in extent, but because it is endless in mystery. The map may be finite or infinite. The questions keep unfolding either way. What matters is that the room we inhabit is large enough to hold both knowledge and wonder, both equations and lullabies. The universe does not need to end for it to matter. It simply is, sprawling quietly in every direction we can name, and in many we cannot, an invitation rather than a boundary. At the start, I asked where you were listening from and what time it might be there, whether the question of an edge would keep you awake or carry you gently toward sleep. If your eyelids have grown heavy, let them. If you're still awake, hover in that liminal space where thought softens and attention feels like mist. Let the multiverse be a wide backdrop, not a demand. Let it be a way to loosen the frame, to remind yourself that even in one universe, every second is already vast. And if you like a final smile before you drift, somewhere in one speculative branching, you give a talk about the sociology of mustaches and their ripple effects on parallel timelines. Somewhere else, a llama wanders into a physics colloquium and becomes a mascot for cautious curiosity. Somewhere in the space of possibilities, you make perfect pancakes every time. Here, in this universe, you pause to wonder about edges. That is more than enough. It is its own kind of cosmic magic to be small, to be curious, to be held by a sky that may never end. So we set the question down beside us, not solved, but soothed. Where does space stop? Tonight the answer can be this: it does not stop you from asking. It does not stop you from belonging. It does not stop at the border of your dreams. It opens, and opens, and opens, and in opening, it makes a home of the dark. Let the question rest on the bedside table, like a book left open to a favorite page. The lights dim to embers. The room softens at the edges. Outside, a slow river of stars slips past the window. Quiet as snowfall you can't quite see. You don't need to follow it. Just breathe. On the inhale, the night gathers. On the exhale, it widens. Your breath joins the dark, the way starlight joins the sky, without hurry, without asking to be counted. Far above, galaxies keep their patient distances. Nearer, the air folds around you like a low tide. We don't need endings here. Only a gentle, easing a door left ajar so the mind can wander. The universe will go on opening, whether your eyes stay open or close. Let the last bright thoughts fade to ash, the way constellations fade behind a thin cloud. Still there, just softer. If wonder returns, let it pass like a small wave under a boat. If sleep arrives, let it take your hand. Tonight the cosmos doesn't ask for answers. It only asks for quiet. Set the question down. Feel the room become part of the dark and drift slowly, steadily, until the stars are just your breathing, and your breathing is the night.